So welcome to our final NAC Ask Me Anything webinar of the spring semester. My name is Susan Bogus. I am an NAC member and the interim chair and AGC endowed chair professor of construction engineering and management at the University of New Mexico. The themes for spring 2024 are focused on sustainability and resilience and the use of new technologies in construction. The National Academy of Construction was established in 1999 to recognize our industry leaders. An important purpose of the Academy is to share the collective knowledge and experience of our members to improve the industry. We have established the NAC Ask Me Anything to help transfer knowledge of our members to our next generation of construction leaders, with this webinar providing a means to link past and present participants in the construction industry. Our Ask Me Anything sponsors this year are the University of Florida Rinker School of Construction, Arizona State University Del E. Webb School of Construction, and the University of Colorado at Boulder Construction Engineering and Management. The format for the Ask Me Anything is simple. Our speakers will make a short presentation about a topic and their perspective on the industry, followed by time to answer your questions. If you have not already done so, please email your questions to nacama@austin.utexas.edu. And we've put this address into the chat in case you want to send in some more questions. One student will win a $500 scholarship, which will be announced at the end of this event. So now let me introduce our speaker. Doug Morton is Associate Vice Chancellor for Facilities at North Carolina State University. He holds a bachelor's degree in civil engineering construction from NC State, a master's in civil engineering from Georgia Tech, and a master's in national resource strategy from the Industrial College of the Armed Forces. He previously served more than 3 decades with the U.S. Navy Civil Engineer Corps, responsible for all facets of project delivery. He commanded Naval Mobile Construction Battalion 133, Seabees, deploying worldwide during the global war on terrorism, the Naval Facilities Engineering Command Southeast, providing military construction support for 23 bases, and NAVFAC Atlantic, where he oversaw all Navy Marine Corps construction activities in the continental U.S., Europe, and Africa. Doug was awarded the Morrill Medal by the Society of American Military Engineers, SAME, for the most outstanding achievement to military engineering and construction and administration for his leadership of Seabees deployed to Croatia and Bosnia in support of the Army and NATO peacekeeping operations. Currently at NC State, he leads all planning, design, construction, and maintenance, and has a more than $1.3 billion construction program for North Carolina's flagship STEM institution. He retired from active naval service in 2016 with the rank of Rear Admiral. Doug is a registered professional engineer in Georgia and a fellow of SAME. So Doug, welcome, and very glad to have you here today on Ask Me Anything.
Thank you so much. I will share my screen to give you a little bit of insights into what I'm doing today. And there you have it. So I am in Raleigh, North Carolina, and it's a good time to be here with both our men's and women's teams in the Final Four of the NCAA tournament for basketball. That's our mascot covered in confetti. It's not bragging because it's been 41 years since we were last in this tournament at this level. So it's really celebrating. And so I wish you all success the next time around. So I'm going to talk a bit about the role of being an owner or an owner's representative. I've been that for my adult life since graduating from NC State, both serving in the Navy and then back at my alma mater. It's a different kind of role where you have to balance the needs not only of the institution you're serving, but those who are supporting that. Those would be the taxpayers, both nationally when I was in the Navy or here in the state of North Carolina. So there's a lot of interest, a lot of stakeholders that you have to balance their needs. And so tonight I'll talk about 2 different items. One is the idea of sustainability, and I put up on the screen the United Nations Sustainable Developmental Goals. There's 17 goals, and they are broad. They cover all of humanity and how humanity interacts with the planet and with each other. And at NC State, we don't pretend that we can solve world peace per se, but we have a finger in all of these items, both in our communities and trying to instruct our campus population, primarily students. We have an active program between my staff in the facilities division and the student population with what we call campus as a classroom. So we look for opportunities at NC State to share learning experiences with the students, some of which they create for themselves and we help them, we mentor those students, but others that reach out in the community to make a difference here in North Carolina. So these 17 goals are aspirational. You can just read through a few of them. No poverty, no hunger, good health and well-being. This is for everybody. And so the great part about being a part of a R1 STEM institution is that we can literally create solutions for these issues that face our planet. And so we do our best to coordinate with the faculty and the staff here at NC State to bring our students the most enriching experience so then they can leave NC State and truly make a difference wherever they land. I'll look at a couple of buildings that we built. And again, some of these very much with sustainability in mind. NC State University and the state mandate that we reach leadership in energy and environmental design, LEED Silver standards of certification for all of our buildings. This is about a decade-old building called the James Hunt Library, and it's renowned not only for its unorthodox design and shape, and I'm a little worried about 10 years down the road when all that glass starts leaking, but so far so good. But inside the building, we've really thought out the use of space. And what you see here is maybe it's hard to see, but all of those metal boxes with the handles, that is our book stacks for this library. And it's not a traditional go in and browse through the Dewey Decimal System. This is what we call the book bot. And we saved about 40% of space in housing over 2 million volumes in this collection. And this retrieval system runs automated to pick up the box where the book is located. You'll see in the center of the screen that yellow conveyor has a box full of books. Let me get this back here. Has a box full of books, again, only labeled by the computer as to where they are stored in that book bot stack. And the book will be retrieved within about 30 minutes from a student going in the computer saying, I need War and Peace. Where is that housed? That book will be retrieved back to the desk where the student will eventually get the book. Books not being retrieved will eventually be cycled toward the far end of the stacks and then be taken to satellite storage. The energy savings in this space also is remarkable because you do not need lighting for the computer bot to work. And you don't need to worry about the energy because it stays at a static temperature. There are no doors and windows to be moved, open and close. There's not traffic here. So it's just mechanical systems, computerized systems that do this work. So quite remarkable. Have a lot of visitors that come into our campus just to see how this library functions. Another building with the library in the far left background is our newest building for engineering. It houses the dean's office, civil, environmental, and construction engineering, as well as industrial and systems engineering. Again, this building met the leadership in energy and environmental design silver certification. It's about 225,000 gross square feet, and it houses laboratories in the basement and again, academic and teaching spaces above. This is where the worlds of sustainability and practicality cross, because the effort on the campus was we need to have more renewable energy sources in our campus. And so the push was we need to make this solar friendly, if not solar reliant. And in reality, without tax credits, in our hands, we couldn't really afford the green power because in North Carolina, the brown power was cheaper. So we ended up getting some gifts from philanthropists, from alums, and some support from a local energy company to actually test out a solar array on the roof. And the thing that tipped the scales was the idea of a battery storage system. So solar in its own right was not going to carry the day financially, but the battery storage allowed us to collect that energy from the roof of this building and then store it for future use, typically in a time where we would try to be trimming the load to watch our peak demand. So again, the practicality of trying to be sustainable meets often with the economics of that. This building, remarkably, with the large biosafety level 3 greenhouse to the left top on the roof, met LEED Silver certification. And I'm still kind of scratching my head, was it that last bike rack that we put in that got us over the top? But it is remarkable. And how we manage the energy in this building, if you'll notice underneath the greenhouse to the left, there's a dark level of that building to the left. And that dark level, there are no windows there. That's the mechanical systems exclusively for the greenhouse. Exclusively for the greenhouse. Again, because biosafety level 3 means that we have to isolate the work on plant science that goes on in that greenhouse from any outside air. And so all that is worked through that mechanical space. But this is where we are literally trying to feed the planet. We're doing research on disease-resistant plants, drought-resistant plants. How do we increase the production of an acre of arable land anywhere in the world? And we try to mimic that in both our growth chambers and the greenhouse that they're on the roof. They have this building here, the Integrative Sciences building. It's chemistry and biochemistry. It's underway. This is a rendering of the completed project. I found myself as the owner's rep, having gone through those previous 2 buildings and seen what things cost and how excited the design team may get to do the greatest thing they've ever built and what I could afford as the owner. I implanted myself as the chair of the building committee in this building, a practical use of my time to try to hold down the appetite of the iconic building or the incredible structure. An example of that, you see in the foreground, a 2-story appendage to the building with a green roof. And there were designs to make this green roof just over the top. And I think at the end of the day, you're not going to see that complete rendering of that green roof because the cost of building structure to support earth on top of a typical roof and plant material and make sure that it's waterproof, it got out of control in terms of the cost and the real feasibility of that. And it really didn't save any greenhouse gas or any remarkable change in the environment. It was really a feel-good part of the project. And so I think at the end of the day, we have a modest amount of green there and a reflective roof. This is the north-facing side of the building, so it doesn't really get much sun other than middle of day. The foreground is the part of this project and the technology we're using that is not terribly advanced, but it's very important. That is our central plaza on our campus. We call it the Brickyard. All of that is made of bricks. And you can imagine if it rains on bricks, the water just rolls off those bricks downhill to the nearest sink. And that happened to be the basement of the existing chemistry building where we have millions of dollars worth of equipment. And so we were doing everything we could to try to divert this water, which comes from a shed that's at least 3 blocks off of our campus through the city, and it lands here in this Brickyard. So working with our College of Natural Resources, some professors there doing research on water retention and stormwater management. What this will be at the end of the day is a pond, about a 2.5 acre pond that will hold several million gallons of water in about a 3 or 4 feet deep gravel bed. And those pavers that you see, those bricks will be permeable. They'll have edge nibs on them that'll allow the water to soak through that brick surface into that gravel pond underneath the yard, and then we'll be able to discharge that water at the pace we think that the systems can hold. And so at the end of the day, I'll know that this is a pond and you'll know it's a pond, but the average person walking across that brickyard will know it is a brickyard. But it'll save a tremendous amount of damage to the ecosystem downstream from this project as we hold that water and release it responsibly. So those are the slides that I had to share with you. And again, as the owner's rep, it is a balancing act. And imagine in your universities, the people that are interested in saving the planet or doing their bit to not pollute or to hold back in the resource use, how difficult that is when you have to pay for it, how easy it is when you don't have to pay for it. And so that's the challenge I have here, is limited resources. And again, trying not to become too cynical, because I realize the desire to be responsible stewards of the environment, but trying to balance that with the practicality of what things cost. Last I'll leave you with is this idea of net zero. And again, that's an admirable goal to reach for, but we're often missing the level of effort and the cost, both in material cost and cost to our environment, and what it takes to build a building. And not, the number of bricks, but where the bricks come from. Not the steel, but where the steel comes from, and how much carbon is embodied in the manufacturing of those materials. And you might say, well, this is an energy efficient building, but was it really? And so you have to look at the full cycle of the build, through the design, through construction, because the operations of the building often is the least energy intensive piece of what you've done. And so embodied carbon, I believe the New Buildings Institute has published some codes that give the designer and the owner a really strong idea about where they are using carbon in that build. And so it's pretty complicated, but if you are looking to be the designer or you're involved in that process, it's a good place to start, just to build your awareness of what is really taking place in the full cycle from design through construction and maintenance. And again, that same guide offers the notion of what it takes to recycle a building. The last picture I showed you of the integrative sciences, we had a building on that site. When we took it down, we recycled or reused 95% of the material. There was limestone and steel and concrete. Some of it remains on site in artwork that was made out of those pieces, but others, from the chairs to the marking boards in the building, were recycled through excess. So it is a complex environment we're in, and if we're all out to make our planet better and more sustainable, you're in the right place as a student to continue to study that, but get out and don't take no for an answer. Get involved, provide your idea to the environment you're working in, whether that's a public or private sector, and you can make a difference. So with that, I'll take any questions that you have.
Great. Thank you. Very fascinating. I actually hope I have a chance to come visit your campus. Those buildings look beautiful. So we have some questions. Maybe I'll start with one here from David. What are some cutting edge building materials or techniques that support industry sustainability?
So in our buildings, I would say the materials have not changed remarkably, except for in glazing, where we are putting a lot of glass on buildings, where in the past, as when I was a student here 40 years ago or more, there were a lot of brick buildings with punched openings, and now there are a lot of glass buildings with a little bit of brick on them. So the glass itself and the actual installation of glass, or what we call fritting of glass. So you put a pattern on the glass in ceramic or another material that'll reflect the heat away from the building. And I found that to be probably the most fascinating application as I go through these design projects and watch the designers prop different types of materials up for use. And then with those same window walls, you find the need to shade them in some way without really impacting the facade of the building. So that's metal and glass combined that really breaks down that thermal heat gain on those south-facing walls. The other area is really the unseen area in materials, and that's how you feed your building. And so the control systems, that's primarily for the heating, ventilation, and air conditioning, but it also can be for vertical transportation and elevators or other research-related equipment. How do you find the most energy-efficient systems and then afford them? And the other part of that is, what's the first cost versus the life cycle cost? Sometimes people are scared away by the high-tech piece of equipment that may cost a lot up front, but if you do the numbers, it'll save you tremendously on the back end. And so control systems are a complex creature because you can do a system control or a whole building control, or you can actually do, neighbors or enterprise area control. The challenge is your control system one that will be supported, and is it compliant with other systems? And I'd say right now, the largest challenge we have of all the things is elevator controls. And you probably don't give that much thought, except for if you've been trapped in an elevator, you might think more about it. But the elevator control system, we have 260 elevators on our campus and probably 4 different control systems. And the manufacturer of the system wants to give you the best mousetrap they can give you, so you keep coming back to them. And they're not terribly concerned if it's compliant with another you have. And they also want to sell you the elevator and the maintenance. So that's a problem, because you have 260 elevators, 4 or 5 different varieties. You need 4 or 5 maintenance contracts. So trying to design in a non-proprietary control system is a challenge. But the other part of that is, and I said, are they supportable long-term? That's where you have to be cautious, because technology is moving so fast, and the data collection from sensors is so enormous. We age out pretty quick. And so I find myself buying into a control system that I've got version 1.0, and before I know it, I'm buying version 3.0. And so that's the technology that keeps taking from me. So that's a challenge to either find the one that is more uniform across the environment. Everybody has it, so it'll be fully supportable, but it won't break your back in the long run. Yeah, control systems are the biggest challenge that we face.
So it's interesting to think about technology, taking from you, and this need to upgrade. Several students ask questions concerning technologies. And so Akshitha, for one, asks, how do you see emerging technologies like 3D printing and robotics impacting the sustainability of constructed projects?
It's almost right now novel. And I say novel because I was in the Navy just 10 years ago, and we were trying to figure out how to manufacture parts for aircraft and ships while they were at sea. So you wouldn't have to carry a load of every single part. You could have a 3D printer and a bag of metal dust, and you could make it on site. That's now reality. So again, the technology is moving fast. In the built environment, and I'm watching, and you could go tomorrow to North Carolina State University facilities webcams online, and you could see a webcam of the last building I showed you under construction. And you won't see anything remarkable. You'll see a massive Manitowoc crane lifting big pieces of steel onto a building like you might have seen 50 years ago. And so the basic brick and mortar has not really changed dramatically. and it goes back to the skin of the building. And I'll say this briefly without getting in trouble from our lawyers. You've got to be really smart about the type of materials going in the building. We're dealing with a building that there's some contaminants that were manufactured 50 or 60 years ago that is in almost all of our buildings, PCB, and it's causing problems downstream for us. That it's there, it's in every campus in America. The question is, where is it and how is it affecting the occupants? So being careful to specify, known material substances going in your building and do your research on that. But again, once that skin is there, the glass, the ceiling, the insulation, and again, control systems are really where technology is changing the built environment. The basic structures, other than a couple of interesting types of connections being tried out in steel frame buildings, it's really about how do you skin the building and how do you maintain the climate.
Okay, great. So here's a question from Mohammed about supply chain issues. So how have the post-COVID supply chain issues regarding things like electrical equipment impacted or changed your approach to choosing sustainable equipment and materials for your facilities? Have you faced any long lead times or had to pay extra for sustainable items?
Yes, and yes, and yes again. And it comes from the most unusual places. You might remember in the last 3 years or so, there was a deep freeze in central Texas in the winter, and it crippled the petrochemical industry for weeks there. And here I am on my campus, and I'm putting in an entirely new electrical distribution system. I'm talking about 9 miles of duct bank in the middle of every street on my campus. The old system was neglected and it literally failed. So imagine if you're a research scientist and your building goes dark and it's not a flicker, it stays dark. That's not a good place to be. So we're replacing the whole system. And in that 9 miles of duct bank, there are about 60 miles of 6-inch PVC pipe. And the PVC pipe comes from the petrochemical industry in Central Texas. And our good fortune was that our contractors that were doing the bulk of that duct bank work are conduit contractors. So they had a storehouse of the right kind of conduit to get ahead of that. But I was fearful that we would just be dead in the water for months waiting on that industry to restart and meet their demand. They're still struggling to get back to full capacity, but that was not COVID, that was weather. COVID created lots of log jams with materials coming from overseas through ports. And again, fortunately for us, we're mostly providing American-made products for our buildings. And make sure that doesn't go away. Can you still see me there, Susan?
Mm-hmm. Yes, we see you and we can still hear you.
All right, so mine says it's going to expire, but if it does, I'm coming back to you. Okay. All right, so Zoom was giving me fits for a minute there. Okay, so I'm back. Again, so where you source those materials is important. And that goes back, I'll go back to your sustainability question. Think about where you source your materials. We have a forestry school here at NC State, and the department head, it keeps asking me to build the next building with cross-laminated timber, which has been studied and shown to be quite eco-friendly for the environment. However, he keeps coming to me when I'm in the middle of design, and I've already designed a steel building or a concrete building. And so now I've got it in my head, all right, what's next? And so I've got an engineering building in the next 3 years on the design table. So cross-laminated timber is a product where I can source that closer to the campus. So again, not buying steel from Pennsylvania or somewhere far away or shipping it to me. I can get cross-laminated timber within 100 miles of NC State. And so I save on the type of material and the transportation of the material. So I'm going to investigate, how do I use this? And there are mid-rise buildings, 6-7-story buildings that have been built out of this timber material, both office buildings, apartment buildings. And so I'm fascinated by that opportunity to try what seems like an ancient technology, but the way they've developed the use of that dimensional lumber, it's fire resistant. You think wood is fire resistant, but the way it's put together is, in terms of its rating, and again, how far it has to travel to get to me, and again, what it took to actually develop that tree. That was a carbon sink for its life, and so we're going to get some very important environmental gains out of using that material. So I'm looking forward to that type of material. But think about distance, think about manufacture. You'll be surprised at what you're really doing to the environment before it gets to you.
Great, great. So here's a question from Gabriella. How has the development of new technologies in construction affected the time it takes to complete a project, and has it improved safety conditions on the work site?
Time, I'd say it's really not material condition. It is more a project management support in terms of how you track activities on a job, how you track material deliveries, the visibility of every step of the supply chain is at your fingertips. And then your trades people can also better coordinate, whether that's using BIM modeling for your utilities, or scheduling software for all the different trades, all the different subs are lined in to one particular tool. And so communication becomes a lot more seamless. The company building our latest building is Skanska, a large international firm, and they have given us a tight schedule, and they know what's happening next Tuesday at 3 o'clock and the following Wednesday at 1. They've got it really tightly wired, and their whole group of subs and their supply chain are linked. And so I think that technology, that information sharing, is what really will drive the speed. In terms of safety, we are safety zealots at NC State. We work hard with our contractor community to provide them guidelines. Again, they already have that from OSHA or from the Code of Federal Regulations, but we reinforce that with them, and then we engage with them in lots of different ways. They have safety events that we find ourselves participating in. We have video footage of the project sites around the clock. That webcam that you'll see if you go onto that webpage will show most of the job site that's in play right now. And so it's information sharing, and it's again back to the good old handshakes, where we work with those contractors to ensure that they understand the requirements and we support them. In terms of technology, again, information sharing is really the most important piece, but it falls back to relationships. And Skanska wouldn't be our construction manager for this job if they didn't have a track record of treating their employees well, providing a safe work environment. So I think that's part of the equation as you're evaluating who you work with. What have they shown you and their employees in the past? And you go with somebody who really knows how to provide the right environment from their workforce. I don't remember, Skanska's done 3 buildings here in the last 10 years. And I know there's been no fatalities, and I don't really remember the last time an ambulance showed up to one of their job sites. So they have got that figured out. And again, it's about relationship with your workforce and your subcontractors.
Very interesting. Very interesting. Several students had some questions related to your years in the military and your experience there. So Shubhang has a question about, how does your military experience inform your ability to discern when to prioritize sustainability and when to prioritize ideas that may conflict with sustainability?
Well, I'm thankful for being able to serve in the Navy for as long as I did. I joined in 1983 and thought I might spend 4 or 5 years there, and 34 years later, I came home to my alma mater. My experiences there, though, exposed me to the planet, and I was able to see clearly those societies that have resources and how they use them, and those that have little resources and how they still uh, make do and find joy in living. And that's part of engineering's grand challenges, to create joy in living. And so that experience in the Navy exposed me to how that could happen, in any environment. And I've been to 50 countries in my life, in all but 2 states. And I'm sorry, Vermont and North Dakota, I might never make it there. But the exposure to all those different cultures and societies really gave me insights into what was important. Prioritizing sustainability over things that might not be sustainable, that's not really the choice that we make, because we've chosen at NC State, and I think in the Navy as well. I can think of an example at an airfield I worked in Florida, where we had a lot of laydown space, apron space for a helicopter squadron. And in those spaces, you want to eliminate foreign object damage hazards. They call it FOD, little pieces of material that might be sucked into an engine or washed by a rotor. And we figured out how to install permeable pavement in as many places as possible so the runoff of the water was minimized, and still meet the mission and the safety concerns of that squadron of helicopters. So the trade-offs may have to be made at the end of the day when there's not a technology or a solution. But I think I've gotten way past that to say, I won't do it because I find a way to do it. And maybe that goes also back to my Navy upbringing. I was in the Navy construction battalions, the Navy Seabees. Please look them up. It's a remarkable story starting in 1943. But their motto is can do. They say the difficult we do it once, the impossible takes a bit longer. And it seems a little cocky until you notice their story is wrought with stories of them doing the impossible. So here, I really relish somebody saying it can't be done and then finding the way to do it. And what that takes, back to the relationship idea, is to determine the outcome you want. So I want either a LEED silver building or better. I want an environmental friendly environment. How do I get there? And if I, as the owner, make that my stated outcome, then the whole team has to participate. The designer has to participate. My project management team has to participate, and the end user, the college or department that might have use of that facility. So the trade-off may at some point come down to there's no available material or no available technology at the price that I can afford, but then I keep looking for ways to offset that impact elsewhere in the project. And I've not failed yet, even in that energy intensive greenhouse building, to reach that sustainability goal that we set.
Great, great. Okay, I always like to kind of wind down the conversation by moving on to some career advice questions. So here's one from Shayla. Is there anything in your career or education that you wish you would have known as a young student or professional, or wish you would have done differently?
Shayla, I have no regrets because everything that I experienced, and this really came from great parenting and early mentorship, that I remember the first boss I had in an operational unit. I sat down in his office. I was scared to death. I was a very young officer. This is an old salt. He goes, I want you to make mistakes. I was flabbergasted. I hope my face didn't show it. And I was like, oh my God, what does he mean? He goes, but just once. He goes, when you make mistakes, I want you to learn from them. I want you to keep your eyes open and understand the environment around you. And so, sure, I made mistakes along the way, but I tried not to repeat them. And thanks to people like Jack Reaver, who was my mentor in that setting, I had license to learn. And as I teach a leadership and strategy course here at NC State. I talk about the value of just that if you pick the profession that you like, that you're drawn to, I'd say that's in the neighborhood of being passionate about something. But I ask you to find fulfillment in that choice. So if you choose something, I'm really fascinated by high-rise buildings, and you get into that field and you're like, I don't like this at all. Go somewhere else. You know, don't belabor the point. You didn't find the thing that was really going to be fulfilling for you. But find fulfillment in the work, and then do everything you can to learn all you can about that work, to become an expert in that work, and it'll serve you well forever. And then this is the trick for the young person, and you think, I'll get this right out of the bat. You will not. You have to experience projects or failures or other things to grow your perspective, to get the context for why it is I'm doing what I'm doing, or how did that happen the way it happened. And that's the wisdom of years. And as I tell my students here at NC State, you know, if you're 24, I'm sorry, you just don't have enough runtime to be all wise. You might be wise for 24 because you paid attention, but be patient with that and take a lot of notes, mental and otherwise. You know, journal your life and refer to it, because if you are truly wanting to be successful, you'll be that born out of the experiences that you have, not somebody else's experiences, but yours. And so it is find fulfillment, learn about the thing that you're doing, and then try to understand why things are happening around you the way they are. And you'll be just fine. Don't be too anxious to be great tomorrow. Be great in your effort, but know at some point your expertise will come to full bloom and you'll be just what you hope for.
Wow, fantastic advice. Here's a question. Now we want you to get out your crystal ball, or, you know, think about the future. Gabriella has a question. With the push for more resilient infrastructure, do you see a need for a shift or an update in the civil engineering and construction curriculum?
Sure. You know, I think that the mix of the research and the idea, you know, evolution of great ideas mixed with the practicality, those two blended together will create the right kind of change. I bristle when somebody says, hey, I've got this great idea, and people kind of walk the other way. I'd say when somebody has a great idea, you perk up and you listen to what they have going on. You know, lightweight concrete, this idea of cross-laminated timbers in use. I remember in my undergrad talking about glue laminated timbers. It's a different product, but in the same idea, and that evolved to something that might be more readily used in construction today. You know, the data capture in project management. All those things are beneficial to us. And so as you hear those things, you know, lean in, read about them, learn about them, you know, subscribe to journals that, you know, it's not as fun as watching NC State basketball, but that, like I said, it only happens every 40 years. So, you know, read as much as you can about the field that you're in, and then start asking questions of your designers, your colleagues. That's where change takes place. But yes, we need to figure out materially how to change the industry. And I think that's been glacial, and how that's changed over time. I told you, go look at my new building. It looks like the building we built 30 years ago from the inside. Maybe outside it'll be different. So materiality has got to change at some point, maybe lighter weight materials. But again, I caution you to be careful with the chemistry of those materials, because what seems like a good idea today might be something that really cripples you in the future. So yeah, but keep learning.
Okay, one last question here. I think we'll end here with this question from Hoda. So looking forward, this is the crystal ball question. What key trends do you anticipate will shape the future of sustainable and resilient construction?
I think it is how you energize your buildings. So for me, I'm on a campus, so I have the benefit of having a district energy system, but it's kind of antiquated. The most remarkable technology I have is cogeneration, where I have a natural gas-fired turbine generator that creates electricity, and the heat coming off of that helps me make steam to cycle through my campus. But I have some property, and I need to think like the University of Virginia is thinking. They're doing geothermal heat and cooling in large parts of their campus. And I'm visiting them to understand how they were able to afford it or fashion that on their campus. Then I can use the earth to help me heat and cool a building instead of creating that out of fossil fuels. And so I think it is the technology and the adaptation of technology that helps us create the right kind of interior climate in our buildings. And if we can figure out in terms of renewable energy sources, how we make that affordable, that's really important. And I don't think affordability is tax credits or renewable energy credits that you might be able to buy if you're an institution with a big endowment. I really mean, how do you generate from renewable sources the energy you need? And we have not gotten there yet, but that is, to me, really the holy grail of the built environment. How you stop using fossil fuels because it's easy, and really go hard in deep thinking about how do you use renewable energy sources. We have not cracked that code here at NC State, and we are constantly looking for the way to do that.
All right, great. Well, great way to end up our question and answer session. We do have a winner selected. Our winner this week this time is Brian Lawson from the University of New Haven. Congratulations, Brian. So before we say goodnight, we would like to say a special thank you to our sponsors, the University of Florida Rinker School of Construction, Arizona State University's Del E. Webb School of Construction, and the University of Colorado at Boulder Construction Engineering and Management. Also, of course, a very big thank to Doug for sharing with us his insights and years of experience in this area. So thank you very much, and we look forward to seeing everyone next semester.